In this video lesson, we're going to learn about estimating the area under the curve using the midpoint and trapezoid rules. Judging from these pictures, you would be right to guess that this is going to be quite similar to what we've learned using left-hand rules and right-hand rules. So let's, with this first example, review what we know about left hand and right hand before we move on to our new rules. So in this problem, we are asked to estimate the integral from 0 to 6 of f of x dx, and we're told that n is going to be 3, so that means we're going to have 3 rectangles. And let's start off with left 3. So if I do left 3, my first rectangle has a height of 0, so that's nice and easy. My next rectangle is going to have this height of 4, and my last rectangle right here is going to have a height of 12. So if we do this right here, we've got a width of 2 and a height of 4, that's 8, and a width of 2 and a height of 12, that's 24, and 8 and 24 together gives us 32. So there's our left hand. Now let's move this out of the way, and let's work on our right hand. So on our right hand rule, here we go. Here's our first one with width of 2, height of 4, so that has an area of 8. For our right hand rule, we come up here. Here's our second one. Height of 12, width of 2, that's 24. And our last one right here has a height of 2 and a width of 2. So that's going to be 4. And when we add that, let's see, 12 and 24 is 36. All right, so far that was just review. And now we're going to do midpoint rule. So because we have 3 rectangles, our width is 2. For midpoint rule, we're going to go up to the height of the midpoint. So between 0 and 2, 1 is our midpoint. We go up to that height and we draw that rectangle right here. And just for our calculations, we're going to say it's about 1. So that area is 2. Here between 2 and 4, we're at 3. We come up to this height here and we draw a rectangle coming across like so. And so we know that this rectangle has a height of 8. 8 times 2 gives me 16. And then the last one between 4 and 6, 5 is right here. We draw this one, and that has a height of 6 and a width of 2, which is 12. And so we get 28, 30. And so in this case, our answer is 30. So midpoint rule is very similar to left and right hand rule, but instead of putting our endpoint on the left or the right, we do it at the midpoint. All right, now trapezoid rule is going to require us to remember our little geometry. So let's just review here. We would normally in geometry call this base 1 and base 2, and we call this our height. And you'll recall that the area formula equals 1/2 the height times base 1 plus base 2. Or you might say the height times the average of the bases, depending on how you learned that formula. Now, when we're doing trapezoids, they're going to be looking a little different. So I'm just going to take this trapezoid. They're going to be standing like this. And when we do it, we're going to be naming these delta x. And this is going to be a height, maybe we call it y sub 0, and this one y sub 1. So now our area equals 1/2. Our height is down here, that's delta x, and our 2 bases are now vertical, and that's y sub 0 plus y sub 1. Or we might think of it as delta x times y sub 0 plus y sub 1, the average of them. All right. So let's take a look at what happens when we do a whole bunch of those in tandem. So here I've got a curve, and I've got all my different y values, and every width is delta x. And so if I'm using trapezoid rule, what I'm getting is all of these trapezoids. And in this case, it's quite a nice estimate. You can see how it would be a better estimate than, say, using left hand, right hand, or even midpoint rule. So here we go. We're going to find the area, and let's we're going to compare it with left hand and right hand rule because we're going to see something nice happening. So we're actually going to do our left hand rule first. So in our left hand rule, our width is delta x, and each of the rectangles, which I didn't draw in, but they're going to be, of the 4 rectangles, we're going to use the left hand. So y sub 0 plus y sub 1 plus y sub 2 plus y sub 3. So you recall with left hand rule, we use the first 4 y values, whereas the right hand rule, width of delta x, and we're going to have y sub 1 plus y sub 2 plus y sub 3 plus y sub 4. So we're going to use the y values on the right-hand side. Now for trapezoid rule, we're going to start off by figuring out each trapezoid. So I'm going to have delta x, and we said we would, let's look back at the formula here. So we were going to do this formula here where we add our y's and divide by 2. So let's go ahead and do that. So our first trapezoid, y sub 0 plus y sub 1 all over 2. And our second trapezoid, also delta x, y sub 1 plus y sub 2 all over 2. And our third trapezoid, y sub 2 plus y sub 3 all over 2. And then our fourth trapezoid, we've got delta x, y sub 3 plus y sub 4 all over 2. All right, now what I'm going to do is factor out this delta x here. And I'm going to get all these y sub y values in, and you'll see they all look like this. So I'm just copying them all over, plus y sub 3 plus y sub 4. And that whole thing is over 2. I'm going to write the 2 there right now. Now I'm going to rearrange these so that I'm going to take some of them and put them in one parenthesis. So I'll highlight which ones I'm doing. I'm going to take this one, and this one, this one, this one. So I'm going to take every other one and put it in the first parenthesis. So let's go back to my red pen here. There we go. So I'm going to have y sub 0 plus y sub 1 plus y sub 2 plus y sub 3 plus, and I'm going to keep this delta x times those, and then I'm going to have the next set, which are the ones I didn't highlight, y sub 1 plus y sub 2 plus y sub 3 plus y sub 4, and that whole thing is over 2. So let's just convince ourselves that these are the same. I would take delta x times every one of these. Same thing here, delta x times every one of these, right? And then I'm dividing the whole thing by 2. Now, if you see where I'm going, you should notice that, oops, that this first expression right here, I'll use my highlighter again, this expression right here is the same as the left-hand sum. So that means, oh, and let's get the other one. And this expression right here is the same as the right-hand sum, which means the trapezoid rule is equal to the left-hand sum plus the right-hand sum all over 2. So that's one way to remember trapezoid rule, and probably the easiest way. It always works, and certainly our book uses that way. I'll just point out that there is one other way to look at trapezoid rule, and that is if I go from this line right here, I can say, okay, I've got delta x over 2, and my coefficients go like this, y sub 0 plus 2y sub 1s plus 2y sub 2s plus 2y sub 3s plus y sub 4. So it looks very much like the trapezoid formula. My base, delta x over 2, and my first y value I have once, my last y value I have once, but all the others twice. But I'm going to tell you something right now is that most students have the best luck using, oops, I don't like that highlighter. Let's pick a different one, using this rule right here. So that's the rule that we're going to use most of the time because we're so good at left and right hand rule. We just figure them out and average them. And you're saying to yourself, well, I did that already. Average them. I just didn't have a name for it. All right, so let's go ahead and do that on this next one. So if I ask for the trapezoid rule on this one, and I've got the values from before for left and right hand rule, our trapezoid is simply going to be the average. We don't have to do any more work. We just know that it's going to be 34. I want to make sure you know what that's going to look like. Here's our trapezoids. There's one. Here's the next one. And then the last one. And we don't actually have to find the area of each trapezoid because we just prove that it's going to be the average of the left and right hand sums. All right, so in this next problem, I'm going to ask you to use trap 2 and mid 2. That means 2 trapezoids and 2 midpoints, and we're going to be estimating this integral right here. The integral from 1 to 2 of 1 over x dx. All right, so let's start with trapezoid 2. If I'm going to have two trapezoids, I'm going to start off by making a table of values here where I'm starting at 1, and if I'm going to have two of them, I'm going to need a value in between, so 1.5. And so when I plug 1 into here, I get 1. When I plug 1 into this, I get 1 over 1.5, and then 1 over 2. So to do trapezoid, remember I'm going to do left plus right all over 2. So if I'm doing my left, I see that the width of each one is going to be 0.5. So I'm going to do 0.5 times those left y values, so 1 plus 1 over 1.5. So there's my left. My right hand, my width, I should point out both widths are 0.5, 0.5, and its heights are 1 over 1.5 and 1 over 2, and then I average those. And so let me just pull out a calculator here to get these values for us. So 0.5, 1 plus 1 divided by 1.5 plus 0.5, 1 divided by 1.5 plus a half, and then we divide that by 2. Okay, so here's our value, 0.708. All right, so we've done trapezoid. Now let's look at midpoint. Now for midpoint, we actually are going to need some other values in our table because we need the midpoint between 1 and 1.5. So our widths are going to be the same, but we're going to need a few more values. So I'm going to just extend my table here. So I had 1, 1, 1.5 was 1 over 1.5, and 2 was 1 half. Now I still have this width being 0.5 and this width being 0.5, but I need the midpoint. So the midpoint's going to be when I plug in 1.25, which is 1 over 1.25. And here I'm going to have 1.75, or 1 over 1.75. Now the values that I'm going to want to use are those values right there, because they are the midpoints in those two bars. So let's just separate these out. Here we go. So midpoint. Midpoint is going to be a width of 0.5, but my heights are going to be 1 over 1.25 and 1 over 1.75. And then we can throw that in our calculator and see what that number looks like. And we get 0.686 if we round to 3 places. All right, now let's just compare that with what we would expect it to be. I've got my little graph here, and so just to see what we were doing here, and we should note that if we look at this graph, we would expect if we drew our trapezoid in that it would be an overestimate, and if we drew in our midpoint, I should have switched the colors on those. Let me go back here. So the trapezoid, I did the work in purple. So there we go. It's an overestimate. And the midpoint, if we go to this halfway point here and draw this, you can see that that would be an underestimate because we're missing this whole big part up here. Now this is actually one that we can do by hand because we know the antiderivative. So let's do that real quick. So if I've got the integral from 1 to 2 of 1 over x dx, that's going to equal ln of x from 1 to 2 equals ln of 2 minus ln of 1. ln of 1 is 0, and ln of 2 is 0.693, I believe. Natural log 2, yep, 0.693 minus 0. So we can see that the real value is 0.693, and like we talked about, trap is an overestimate, and mid in this case is an underestimate. All right, here's another example where we're already given the table and we're asked to do midpoint of 2 and trap of 2. So let's take a look at this one. Now we got to, if we're making two rectangles, I'm going to just kind of sketch in what these would be. We can see that our width is going to be 6 in each case. So if I'm doing midpoint, my delta x is 6, and my heights are these middle values right here, 97 and 78. So I've done two rectangles and a quick throw in the calculator, and I get an answer of 1,050. Oops. And if I'm doing trapezoid, then I'm going to take the left hand plus right hand and average them. So left hand, we have a height of 6, and let's see if this first one on the left is 100, and the first one on this one is 90. A right hand rule on the first rectangle is going to have a height of 90. Right hand on the second rectangle will have a height of 55. And we'll put all of that over 2. And so we've got, let's see, 6, 100 plus 90, and we get 1,005. All right, so we see how to do these, and last thing we want to do is talk about overestimates and underestimates, and we're going to be looking at 4 cases here that we should be familiar with. So in this first case, we are strictly increasing, which means we're always increasing, versus down here where we are strictly decreasing. Now we're going to look, we've talked about this before. If I, and I'm going to just do 2 rectangles to save myself some time here. If I do left-hand sums here, you can see that those are going to be below. And if I do the right-hand sums, which will be the red ones, they're going to be above. So in this case, if I am increasing, the left-hand sum is less than the actual value. We'll show the actual value as being the integral from a to b of f of x, and is less than the right-hand sum. So the actual value is going to be between the left-hand sum and the right-hand sum, which means the left-hand sum is my underestimate, my right-hand sum is the overestimate. In this case, we get the opposite. When we do a left hand, we can see that it is above because it is decreasing. And if I do a right hand, we can see that the right hand sum is going to be below. So in this case, the right hand sum is less than the actual value, and the left hand sum is greater than it. Okay? Now, what's new is looking at when it is concave up and concave down. So here we have one that is concave up. And in this case, we're going to compare our trapezoids. If I drew this trapezoid on this concave up graph, you can easily see that if it's concave up, the trapezoid is an overestimate. So here's our actual value, and we're going to say, okay, trap is an overestimate. Now let's take a look at midpoint. Now when I do midpoint, when I'm concave up, I am increasing at an increasing rate, which means this midpoint is less than halfway up. And you can see that it actually, in both of these, gives me an underestimate right there. Because when I find this midpoint, you'll notice that if I look at all these y values, it's less than halfway up because this thing is increasing at an increasing rate. So we see that in this case, our midpoint is an underestimate, and that happens when it is concave up. Now in contrast, when we are concave down, we'll start with the trapezoid just because it's very easy to see. So here's our trapezoid, and we can see that the trapezoid, the line there lies under the curve. So trapezoid is clearly our underestimate. And then let's see what happens with our midpoint. Now we are increasing at a decreasing rate, which means when I find this midpoint, I'm more than halfway up. And so you can see that this is actually going to be an overestimate. Same thing here. If I take my midpoint, you can see that I am overestimating that. This one's pretty close, but you can still see that this part is larger than this, even with my poor drawing on this bamboo tablet I use. All right, so a midpoint is over here. All right, you should be all set to do your homework on midpoint and trapezoid rules.